When you're looking at this transistor and trying to determine whether it's an NPN or a PNP, if you see the arrow and it goes toward the base, you can go back to the very beginning of the chapter, the very first page. You see the arrow goes away from the base if it's an NPN. So for this problem number 1, it's a PNP, the opposite of that. You look over here on this one, the arrow is going away from the base. And on this one right here, the arrow is going away from the base. That makes it an NPN transistor as well. On that particular problem, if you choose the path that makes a kind of horseshoe appearance, it's the easiest one to work with. Because you start with 0 volts right here, and then it's a positive and a negative like this, 0.7 volts across this. The reason I know that is because up here in the statement of the problem they say between the base and the emitter it's 0.7 volts. And since I have my positive voltages up here and negative here, it's positive right there and negative right here. If I start here, that's 0 volts, and then I have a 0.7 rise because I go from minus to positive. So 0 volts, 0.7 rise. This current has to be going this direction because I sub E is equal to I sub C plus I sub B. Here's I sub C, I sub B, and I sub E. These two have to add together to give that one. I sub E is always the one with the arrow on it. So if the current is going this direction, that means this is positive and this is negative. Conventional current comes along, build up of positive charges here. Back to the beginning, 0, minus 0.7, and then, wait a minute, I said that the wrong way. 0 plus 0.7 plus I times 10 kilo ohms, and that I happens to be the base current because it's going into the base. That's what I have is 0 plus 0.7 plus I sub B times 10 kilo ohms equals 0. You can use that equation to figure out what I sub B is. Like in the previous problem, once you know I sub B and beta is given in the problem, you can find I sub C. So that'll tell you what that value is here. Using this sum expression right there, this one, you can find the third component, which would be I sub E. That would go over here. Definition of alpha is right here. That would go right here. To find capital I in V, go back to the circuit diagram and realize that I is the same as the collector current. Also, since you know this is 10 volts and you know what the drop across this is from 2.7 kilo ohms times this I, you can tell that it would be this minus the drop here would tell you what the voltage is at that point. Alright, and some of these other problems down here at the bottom are very similar types. I don't even know what that one is doing in there, so let's just exclude that one. These problems here are just like this, similar kind of approach where you know what the base emitter voltage is, the 0.7, and you kind of find a Kirchhoff law path to figure out what the base current is for the most part. In problem 13, that's supposed to be a 13, and I guess it's 45 if we're talking about the new textbook. And it's part C, so that would be this one. So here is the emitter, one with the arrow on it, and that means that if we're looking at positive here, negative here, we've got positive and negative. That's 0.7 volts because it's a real transistor. And so we start with 5 volts in our equation. We have a conventional current flowing this direction. So for this, it's a positive here and a negative right there. Is that right? That's completely wrong. Sorry. Goes back the other direction. Go from positive to negative. That right there is I sub E because it's going right into the emitter. I have a positive here and negative here across the resistor, not to be confused with this positive and negative, which is across this NP junction. I know that's really tiny. I'm just doing the best I can here. So I start with 5 volts, and then I do a drop of I sub E times 1 kilo ohm. I have the 0.7, which I go from positive to negative. It's a drop of 0.7, and that brings me down to 0. I then get an equation that has only the emitter current in it. We have to do a little work on our beta equation. starting with the definition, doing a substitute using the sum expression, getting I sub E over I sub B minus 1. Working on that a little bit, I find that the base current is equal to the emitter current, which we found previously, divided by beta plus 1. Beta, remember, was 100 for this problem, so it's 101 in the bottom. That allows you to find the base current, and then using the sum expression that I'm calling it up here, you can find the third component. So then you would have actually the base current, the emitter current, and the collector current. The collector current is going to be the same as this capital I, which is what I've been using for these blanks over here. And the voltage drop across this would basically be the voltage drop across this resistor, IR, and then have minus 15 here. So let's see, if this was positive and negative, we'd have negative 15, and then we'd have a rise if we go in this direction, negative 15 plus I times this equals V. Since you know what I is, then you can figure out what V is. All right, hope some of this helps. See you soon.